Indeed a pleasure to be here. I think the point that was made at the end of the previous panel is that we actually confuse machine intelligence with generative AI. And we should stop doing that. So what I wanted to spend the next 10 minutes actually talking about intelligent machines, which technologies are actually evolving that are going to make these intelligent machines even more powerful as we go. But perhaps more importantly, spend a little bit of time talking about how to convert these intelligent machines and combine them with, if you will, artificial intelligence with natural or human intelligence to create what I call as hybrid intelligence, which is likely to actually dictate the future. So let me first start by saying that So actually, when you think about technology, there are actually 6 different technology categories that are at the heart of building intelligent machines. There is sensing technologies, which is actually all about creating observability in very large scale systems. And there is variety of new technologies emerging there. Quantum sensing that can actually do observability at an atomic level. Nano sensing, hyperspectral sensing, which is basically allowing us to see the unseen and actually capture data that will become the foundation for these AI models of the future. There is, of course, communication, 5G, 6G, and beyond. An important point that was made even in one of the previous presentations is actually knowledge engineering technology. It's not about data management. It is actually about knowledge engineering. Because you have to understand ontology of a domain and actually be able to convert data into knowledge, which is going to become the foundation of a lot of the AI models. The fourth category is computing technologies. There are a wide range of interesting, new, novel technologies that are emerging. I want to talk about at least 2 of them. One is called neuromorphic computing. So if you think about today's AI and AI models, they're actually limited by energy consumption, power. But if you think about our brain, it's far more sophisticated and yet it consumes far less energy. So these neuromorphic architectures are actually inspired by our brain, and actually these are actually already showing 100 to 1000x less power consumption compared to today's GPUs, right? The other technology is quantum, which is actually very good at making these AI solutions inculcate what I would call as prescriptive intelligence. So reasoning intelligence is actually 4 types. Descriptive reasoning, what is happening, diagnostic reasoning, why is it happening, predictive reasoning, what is likely to happen, and prescriptive reasoning, which is actually what should I do about it. Prescriptive reasoning is very hard. For example, if I want to find a drug that is specifically designed for a cancer patient, because cancer spreads very differently in every patient, right? That kind of intelligence is prescriptive reasoning, right? Now that problem is very hard to solve today. It's computationally intractable. It'll take months to actually solve that problem. With quantum, you're going to be able to solve that in minutes or hours. So that is another technology that is actually going to power this future of intelligent machines. And then, of course, digital physical AI. The last one is experiential technologies. We've been talking a lot about language and chatbots and so on, but that is just one form of experiential technology. You will actually have many different forms. All your AR, VR, XR, all of that, they are all designed to actually dramatically reduce the cognitive load of actually dealing with intelligent machines, right? So all these combination of 6 is actually what is going to dictate the future of intelligent machines. When you now start thinking about where are we going to go, assume all of these things are actually coming together to create intelligent machines of tomorrow. Where we are actually going is this concept of what I would call as hybrid workforce, where people and machines will actually work shoulder to shoulder with each assisting and augmenting the other. So machines will continuously make people better, and people will continuously assist and augment machines. And this virtuous cycle that is actually getting created is something that we have never seen before, of sort of mutual augmentation and mutual and continuous improvement. This cycle is likely to almost double the capacity of individuals, teams, or organizations to generate value every 12 to 18 months. We are used to 5 to 7% year-on-year improvement in productivity or things like that. So just imagine if it's 10 times more, it will completely redefine work economics in every domain of work. Which means, I often say that only the dynamic will survive or dynamic will thrive. Dynamic are the individuals, teams, or organizations that will master the art of inventing and perhaps more importantly, adopting work next practices, not best practices, work next practices, because you'll have to continuously reinvent the way the work is done, the role of people, the role of machines. And how does this mutual augmentation help you to redefine the future? So that's the second point I want to make. Third point I want to make is that by and large, I would say 95% of what you hear today and the use cases that you hear today are what I call as activity-centric intelligence, which is all about actually making information available at the fingertips of people, or automation at the fingertips of people. When you call a call center agent, capture a transcript, summarize it, communicate back with the caller. Or who is that caller? How important is that caller? That's information at my fingertips or automation at my fingertips. Today, the challenge, the reason why it is not doing actually ROI translation or ROI is hard is because we are still automating activities or tasks and not roles. So these partial FTE automation does not actually accumulate very well. So there is a non-linear translation of the productivity and the ROI savings. So there is a lot more work to be done even on level 1. But actually level 1 is just the tip of the iceberg. I want to actually talk about the fact that almost every knowledge work that we know of is a combination of decisions and actions. For example, I think in one of the previous talks, there was a talk about automating the transcript when a patient is talking to a doctor and actually creating a record. That is actually automating action. The decision in that example is what is the diagnosis and what is the prescription, right? Because there are so many possibilities that from which you have to actually do this. So what's happening is that in almost all domains of knowledge work, there is a huge gap between what I would call as average and elite. In software engineering, in the IT industry, the quality of software you produce today, as measured by software quality measures like time to introduce change-induced error rates, or time to recover from failure in software, the elite software is 100 to 1,000 times better than average software. And by the way, you can say the same difference in best doctor, best lawyer, average lawyer, best customer service agent, best underwriter versus average underwriter. Exactly same gap stays. What is fascinating is that this gap has not shrunk at all over in a decade or more, while the productivity has gone up. And the reason why that's happening is because a lot of the decisions that people make, which actually controls the quality of output or outcome, is driven by a lot of tacit knowledge that people have acquired. And that tacit knowledge acquisition takes a long time. And because of the rate of change in technology and the world, the tacit knowledge is becoming obsolete faster than ever before. Machines are actually much better at dealing with actually rate of change and actually imparting or augmenting my ability to make decisions. So can we imagine, and this is what is going to happen, that every doctor in a small village in India will become as good as the best doctors in Bangalore or Delhi or Mumbai. That is actually human-centric AI, which is sort of the next big leap that is going to happen, that is going to completely transform the way we look at the world. And then there is one more thing, which is that every organization actually sort of, the value that they are creating is actually flattening out, sort of how do you decide when to adapt? When do you actually change? What do you change and how do you actually get to the next stage seamlessly? Sort of this whole concept of continuous or perpetual adaptation is going to become a critical piece of this puzzle as we move forward. So using AI for decisions, not just actions, is going to be where the interesting game in the future is going to come. I just want to say one last thing because I'm out of time, that everything I just said is definitely going to happen. It's not about if, it's only about when. But there are two fundamental challenges that every organization will have to overcome. The first is a technical challenge. Building these kinds of intelligent machines is not easy. It has been kind of, I think there was one comment that was made that in the previous session that things like vibe coding make it appear like extremely simple, but actually building solutions that are trustworthy, that are actually dependable, is extremely hard. I'll give you just one example. This is the first time in our lifetime we are actually building machines that are self-evolving. Right? We don't know how to actually deal with anything that self-evolves. We can't test that because you can't really, all software we have built ever, we could actually test it and deploy it, and it doesn't change by itself. Now here, if it is changing by itself, how do you evaluate? How do you test? All of these problems are known at the moment, not a trivial problem to solve. Lots of work needs to be done. That's why I think the point that was made that we are at an infancy with respect to truly large-scale deployment and value. The second most important point is that when you think about this hybrid intelligence with people and machines assisting and augmenting each other, it is fundamentally changing the roles of people. The role of people is actually shifting from doers of work to trainers and interrogators of machines, reviewer of work done by machines, and perhaps most importantly, owners of critical thinking and creativity. And as machines will become more and more intelligent, which they will, the roles of people will continuously shift. The skills required to do next generation of work will be very, very different than today's work. In fact, what we have realized is that half-life of a skill, the time within which a skill loses half its value, has shrunk to less than 5 years and shrinking fast. What that means that every person will have to go through what I would call as personalized lifelong learning. Because you will actually redefine, all of our children, I can guarantee you, will retrain themselves at least 5 times in their careers. So the concept of education, concept of 4-year degrees, the concept of careers is completely going to get redefined. And organizations will need to actually think about designing for change, not designing for functionality or efficiency. Completely different game altogether. So let me end by simply saying that I think this is an incredible period. I think something that we have not seen before. Don't actually think of this as 20% productivity improvement. I think you're completely mistaken. What the world we are about to get into is actually very different. We will need wisdom, vision, and perhaps most importantly, courage to actually thrive or lead in this transformative period. Thank you very much.